Let's do a double integral. This is just another normal double integral, but it looks like it would be really hard to do with rectangular coordinates. And if we wanted to do rectangular coordinates, we'd have to break the region up into different regions to do an x first and a y first and different things. But these are pieces of circles, and that makes this perfect for polar coordinates. So for polar coordinates, the theta goes from 0 degrees to 90 degrees. So that's 0 to pi halves on theta. And the r goes from r equals 2 to r equals 4. Right? We go from r equals 2 out to r equals 4. And that's our change in r. X plus y is r cosine theta plus r sine theta. And then we have this conversion. The dA is r dr d theta. We don't want to forget this. You want to think of it as an extra r. You can think of it as an extra r, but we don't want to forget that little thing there. So now we're ready to move ahead and integrate. So we integrate in r. If I distribute this r into each term, I'll have an r squared in each term. Integrating that will give me an r cubed over 3. And then we have the cosine theta plus the sine theta, and that's from r equals 2 to 4. Still have the d theta integral to deal with when we're done with the r's here. So let's see, 4 cubed is 64, so we have 64 thirds minus 8 thirds. We have this cosine theta plus sine theta d theta. 64 minus 8 is 56. Take that outside the integral. Take the constant outside the integral, and now we just need to integrate. The integral of cosine is sine, and the integral of sine is a minus cosine. And we want to go from 0 to, oh, this was pi halves. Sorry, I wrote it pi halves at the beginning and then switched it to pi. Missed that later on, so pi halves throughout. And sine of pi halves is 1. So we have a 1 here. Cosine of pi halves is 0. Minus sine of 0 is 0. Minus cosine of 0, which is 1. That looks like a 1 minus a negative 1, which is 2. So this all comes out to 112 thirds as our answer. And that's much simpler in polar coordinates than it would be in rectangular coordinates. And the geometry involved is circular, and that's what we're looking for. When there's pieces of circles in the geometry, that's an indication that we want to use polar coordinates instead of rectangular.